Today we will discuss regarding partially miscible binary liquid mixture, and we will have an idea about the upper critical solution temperature, which is also known as the upper consolute temperature. Now the most popular binary liquid mixture is phenol water system. Now phenol looks like this. It has a benzene ring and a hydroxy group, and water is like this. So there is a high possibility to form hydrogen bond between phenol and water. So here you will get partial negative charge, here positive, here negative. So there is a high possibility to develop hydrogen bonding. Now, owing to this interaction, you will get water, you will find water to get soluble in phenol, and also you will find phenol to manifest solubility in water. But with increase in amount in both the cases, owing to this large benzene ring which is hydrophobic, it will form a separate layer. So it belongs to the category of the binary liquid mixture, which is partially miscible, not completely miscible like ethanol water or methanol water, and not perfectly immiscible. It is partially miscible. Now we will draw the temperature composition. We will have the temperature composition diagram. Now how it looks like. So in this axis we will increase the temperature, and in this axis, in the x-axis, we will increase the percentage of phenol of the solution. So phenol will increase in this direction and temperature will increase in this direction in the diagram. Now we keep pressure constant while performing the experiment. Now when we have 0% phenol, what does that imply? We have 100% water. So we are starting with water. Now we are adding phenol gradually into it. So when phenol is in little amount, it will undergo complete dissolution within the water. So little amount of phenol when added, we have started adding it gradually, and when phenol is taken in little amount, it will undergo complete dissolution. So we will have a homogeneous solution at the start, that is a single solution at the start. And with increase in phenol, so we are moving towards the right of this axis. So with increase in phenol, a point will come where no more phenol will undergo dissolution, that is a saturated solution of phenol in water is achieved. So you are adding phenol to water, phenol is undergoing dissolution. Since phenol has a little solubility, it is partially miscible in water, and as the phenol is increasing, it is going towards saturation. And when the saturation level is reached, going beyond that, that is adding more phenol from that point, you will get a separate layer. So phenol, after a certain percentage, at a certain temperature and a certain pressure, will form a separate layer. So if we perform our experiment at say 50 degree centigrade, then for 1%, 2%, 3%, what it will give us? It will give us a single solution. Now when it comes to 11%, we see at 50 degree centigrade and 11%, it will correspond to this point here. Now if we go beyond this point, that is here, we will get two conjugate solutions. It is conjugate solution. Now the density of water is 0.9997 gram per cc at 50 degree centigrade, and density of phenol is 1.07 gram per cc. So you see, phenol is denser than water. So where do you will get the phenol? Phenol will settle at the bottom of the test tube or the vessel taken. So you will get phenol to form a separate layer and water to form a different layer. Now mind it that it is not pure phenol, or it is not, say we symbolize phenol as this shade and we symbolize water by these dots. So when you get this phenol, it is not pure. It is a saturated solution of water in phenol. So water is in dissolved state within this phenol. And when you are getting water, it is actually phenol. It is actually saturated solution of phenol in water. But this is the picture beyond this point. But below this point, before this point, what is the picture? The picture is, it is a uniform mixture. It is just, actually you will be unable to find the different layer. So it is a homogeneous solution, a single solution. But when you cross 11% at 50 degree centigrade, you will get two different layers. So we get a point in the phase diagram here. Now what will happen when we increase the temperature from 50 degree centigrade for 11%? Now when we increase the temperature, we see for the phenol water system, with increase in temperature, solubility increases. So at 11%, if we increase the temperature, here it is water and here it is phenol. So with increase in temperature, more and more water molecules will go into the phenol, since solubility increases with increase in temperature in case of this phenol water system, and more phenol molecules will go into the water. So this will increase the mutual solubility. So what you will get? It will convert to a homogeneous solution if you increase the temperature from 50 degree centigrade. So you see the whole picture. Here it is single solution. Here it is. Beyond this, if you increase the percentage, you will get two different solution. So I am writing here single solution SS and two conjugate solution as TCS. And below this temperature, you will get two conjugate solution, and if you increase the temperature, you will get single solution. So this is the picture. So at this point, if you add more phenol, you will get two different layer. If you decrease the temperature, solubility will decrease and you will get two different layer. If you increase the temperature, solubility will increase and you will get a single solution. If you decrease the percentage of phenol from this, so you will get a solubility. It will be the two layers will be converted to a single solution. Now, when we increase the percentage, we get two conjugate solution. Now if we will not get this point here. for the higher percentage of phenol. For higher percentage of phenol, you need a greater temperature so that the mutual solubility increases compared to this one. Then the solutions become a single solution. So next point will come here for this percentage. So for a percentage of phenol, for a solution having percentage of phenol greater than 11%, you need a higher temperature than 50 degrees centigrade so that beyond which it will convert to a single solution. So after having all the points experimentally, you will get a plot like this one. Now you see, it is passing through a maxima, and this maxima corresponds to 33 degrees centigrade at P equal to 1 atm. We are keeping the pressure to be constant, and we have the temperature at this point to be 66.8 degrees centigrade. So we are plotting all the points and we see this, we notice this maxima. Now when you perform the experiment, there will be error and you will not get the point accordingly. So you have to draw the average line, and after drawing it, after taking the readings multiple times, taking the average and drawing efficiently this average line, you will get this graph. Now at 50 degrees centigrade, if I draw a horizontal line here, what idea it will give us? See, this is 11% and this is more. This actually looks like this one. So we will discuss with 2 points, say this is A, this is B. Now this corresponds to composition 63%. Now at 50 degrees centigrade, if your solution is below this percentage, if the percentage of phenol is lesser than 63%, then it will be 2 conjugate solution. It will be 2 conjugate solution. But at this temperature, at this pressure, if it is greater than this 63%, then it will enter into this region where we have the single solution domain. So if percentage of phenol increases than 63%, then the total amount of water is eligible for full dissolution, and the layer of water will vanish into the phenol and it will give you the single solution. So this I can write as, this is the single solution domain, and this area is the 2 conjugate solution domain. Now you can check it at 50 degrees centigrade at 1 atm, when the composition is 11%, you have the point here. Below this percentage, the amount of phenol is such that it will be completely dissolved, it will completely get dissolved in the solvent, that is water. So you will get a single solution here. But at this point, saturation comes and no more phenol will be allowed to dissolve in that amount of water. So when you increase the phenol, what will happen? It will form a separate layer and you will get the 2 conjugate solution. Now at this point you get 2 conjugate solution at 50 degrees centigrade. But if you increase the temperature, what will happen? The mutual solubility increases, water molecules will, more and more water molecules will dissolve into phenol and more phenol will dissolve into water. So it will convert to a single solution. So this point will come here. So it will be single solution. Again, after this, there will be less amount of water and it will get completely dissolved within the phenol. So it will be a single solution. And below this, the amount of water is greater than the saturation, so we will have the water will form a different layer. So when we have two conjugate solution, what we have actually? When we have two conjugate solution, we actually have, this one is the water in phenol. It is not pure phenol. It is a saturated solution of water in phenol. Phenol is the solvent, water is the solute. And what is this? It is phenol in water. So it is the saturated solution of phenol in water. Here water is the solvent and phenol is the solute. This is the picture of this two conjugate solution. Now, what about this point? What about this point? You see, above this point, there is no portion of two conjugate solution. So, whatever may be the percentage of phenol, if the temperature of your solution is above 66.8 degrees centigrade, then you will never achieve two conjugate solutions. You will get only single solution. So you can say above 66.8 degrees centigrade, and when pressure is kept 1 atm, when the composition, sorry, it is not 33 degrees centigrade, it is 33%. And when the composition is 33%, you get this point. This is called the upper critical solution temperature, or the another name is upper consolute temperature, beyond which, so temperature greater than this one, 66.8 degrees centigrade, and P equal to 1 atm, you see this domain is not here. So for all proportions, may it be 9%, may it be 13%, may it be 50%, may it be 80%, you will get single solution for all proportions. So water and phenol are completely miscible above the upper critical solution temperature. But below that, but below this temperature, it is partially miscible and will form two different layers, or it will form single solution. That you have to see this diagram. So if it is below 11% at 50 degrees centigrade, then it will give you single solution. But if it is between 11% and 63%, it will give you two conjugate solution. And if it is above 63% at 50 degrees centigrade, it will give you again the single solution. But above this temperature, you will never get two separate layers, whatever may be the percentage of phenol. Since at this point, since above this temperature, it becomes completely miscible, and the self-association, that is the cohesive forces, becomes lesser than the adhesive forces. So beyond this, the self-association becomes unimportant, and there will be no formation of layer of independent layer of phenol or water. So here we will get only single solution. Now what will happen when we mix two different solutions? Say a problem has been given to you, that two different solution has been mixed and shaken thoroughly and allowed to settle. What will happen then? So I will discuss a Bardon University problem which came in university exam in 2012. It was saying that so I am editing the drawing as per the problem. So it is given that at 323 Kelvin, that is, what will it give you? 30 and 20, so 50 degrees centigrade. So this is given. So in the problem it was given that this composition is A and this position corresponds to composition B. Now they have given two solutions. One is X% phenol and Y% phenol. Two different solutions are given to you. One is X% phenol and another given to you is Y% phenol. This diagram was given in the question. They have given you the position of A, B, that is the point below which when the composition reaches you will have a single solution and above which you will get two conjugate solutions, and also here that is the two extreme limits at this particular temperature. And they have given you two different solutions having percentage X% and Y%, and they told you to mix them up, shake thoroughly and allow to settle. What will happen? The question is what will happen to the solution. Now see, what is X? X is greater than A, less than B in composition, and Y is also less than B and greater than A. This has been given in the question. So you can see that X is less than B and greater than A. So what you are observing, you are writing. So Y is less than B and greater than A. X and Y both are in between A and B. So when we add them, you have to add them. So what will it give you? So X plus Y less than 2B and it is greater than 2A. Now, or what is X plus Y by 2? It is greater than A and less than B. Now see, if in the first vessel it corresponds to 100% and in the second vessel it corresponds to 100%, then what will be the composition of the mixture? Say it can be calculated like this. When we add this we get 200%. So for 200% it is X plus Y, and for 100% you must have considered the mixture to be 100%. 200% is meaningless. So what will be the resulting mixture? It will be the average of the two. So it will be X plus Y by 2. So when you mix thoroughly to different composition, solution having two different composition, you get the percentage like X plus Y by 2. You will get the average obviously. So you see what is this percentage is actually the percentage of the mixture after which you get after shaking the two primary solutions and after settling it. So you see the mixture will also remain in between A and B. So what does that indicate? That indicates that you will not get a single solution. So this will be your conclusion. Since we are getting it within the domain A and B, since we are at 50 degrees centigrade, our limits are this, start from this and end at this for two conjugate solutions. And below A we have, left of A we have single solution, and right of this B we will have single solution. But between A and B we will have two conjugate solutions since we are at 50 degrees centigrade. The picture would have been different at some different temperatures. This domain squeezes, contracts as the temperature increases. It enhances when the temperature decreases. Since mutual solubility increases, the formation of the two different conjugate solutions becomes difficult when the temperature increases, and the formation of two conjugate solutions becomes easier when temperature falls, since with increasing temperature mutual solubility increases. So from our analysis we get that the mixture having a composition x plus y by 2 will also remain between A and B. So it will form two conjugate solutions and not a single solution. This will happen to the solution. Also, an important thing you have to mention this thing, that what is that? That it will form, your mixture will form two conjugate solution and no single solution will be formed. No single solution will be formed. Another thing you have to mention, that what will be the feature of the two conjugate solutions? That the mixture, this is the mixture having composition x plus y by 2. It will have this one the phenol layer and this one is the water layer. Now there will also be water molecules here, so it will be water in phenol, but it will be saturated. That means it will have composition as per this point. This will be saturated solution of water in phenol. So this will correspond to this composition A, and this one will correspond to this composition B. Here you have, phenol is greater. Here you have phenol greater. So this will be B and this will be A. You have here more phenol. This is the point where there is more phenol and less water. More phenol and less water. So it is water in phenol solution, saturated. So the two conjugate solutions which are obtained after mixing thoroughly and settling will have composition corresponding to B and A respectively. So these two conjugate solutions will have percentage phenol in between this A and B, but the two layers that are formed will have composition corresponding to A and B. This is the answer. Now if in another question someone asks you to find the degrees of freedom, then you apply the phase rule. You will have three different regions. One is above CST. That is in this domain, above CST. What you will have here? You have F equal to C minus P plus 2. Now remember one thing, here P is kept constant throughout. So there is one restriction which have to be followed throughout the experiment. So we have F equal to C minus P plus 2 minus this restriction. So it will be C minus P plus 1. So phase rule that can be applied here will look like F equal to C minus P plus 1. Now above CST what happens? We have a single solution. So we have one phase. But we have two different components, both phenol and water. So it is 2. So it will give us 2. So we have 2 degrees of freedom. What are they? Composition and temperature. Now at CST, at this point definitely, what will happen? F equal to C minus P plus 1. We have at this CST 2 components, and it is 2 phases, since it is within the domain, and it is plus 1. Now another thing you must notice is that what happens at CST? within this domain, that is within the miscibility gap, this domain, we have two conjugate solutions, where in one solution we get saturated solution of phenol in water, and in another we have saturated solution of water in phenol. Now as temperature increases, mutual solubility increases, and at this point the compositions, you see these two different points, what does it indicate? This indicates that you have less phenol, more water, so it is a saturated solution of phenol in water. And this point, what it indicates? It indicates more phenol, less water, so it is a saturated solution of water in phenol. And with increasing temperature, these 2 points are coming closer, and at this point it merges into one point at this temperature. That is, you will have both the compositions same. These 2 points are coinciding. The composition of two different solutions, that the two conjugate solutions are coinciding. That is, the composition is same. Here the point A and B coinciding. So the composition will be same in both the solutions. So we have a restriction, another additional restriction. So that will be -1. So what it gives us? It is giving us 0. So you have nothing to change here. If you change either composition or temperature, it will be, you cannot change the composition, cannot change the temperature. At 66.8 degrees centigrade for phenol water system, and at composition 33%, you will get the upper CST. If you change any one of these, it will change. You will not get the upper CST anymore. So this is invariant system. Now below CST, what will happen? That is within the domain, within the miscibility curve, it will be, there are two components, two conjugate solutions, means two phases. So it is, so you can change only either composition or temperature. You can change only one parameter, and two parameters cannot be changed simultaneously. Now in next video I will introduce you with the lower CST and solution having both upper and lower CST.